UPD Manufacturing produces a range of healthcare appliances for hospital as well as for home use. The company has experienced a steady demand for its products, which are highly regarded in the healthcare field. Presently, the company has undertaken a review of its inventory ordering procedures as part of a larger effort to reduce costs. The company has an ordering system of 6-week interval from the supplier that began 5 years ago. The supplier was bought by another supplier about a year ago that the 6-week ordering requirement is no longer in place. According to Purchasing Manager Tom Chambers, they need reason for changing the ordering system since it will cost the company of doing so. If there are none, they're just going to continue what they have been doing. We have now on the first line Hazel from BBBR Radio together with Mr. Chambers. Hazel?
Yes, Chira. The UPD Manufacturing is currently under the deliberation on whether to change the company's order system of 6 weeks interval since the changes of their suppliers or not. Earlier, I talked to their purchasing manager, Mr. Chamber, to talk about the matter. So UPD Manufacturing produces a range of healthcare appliances for hospital as well as home use. One of your company's product is to produce high blood pressure testing kit. You manufactured all of the components of the kit in-house except for the digital display unit. Mr. Chamber, is it true that the display unit is ordered at the 6 weeks interval from your supplier?
Yes, you are correct, Miss Hazel. This ordering procedure was implemented by UPD Manufacturing about 5 years ago after the supplier insisted on using it.
So, on what grounds why the company agreed to the supplier's 6 weeks order interval?
Actually, we conducted a study before agreeing to stick with our former supplier. So, here are some of the details when we order at 6-week interval. Since the demand is 89 per week, we have 89 multiplied by 6. We have 534. And by getting the average weekly ordering cost, that is our formula that we will use, and we substitute them. So 89 divided by 534 multiplied by 32, and we have $5.33. So for the average weekly carrying cost, that is our formula. So we substitute them. 534 divided by 2 multiplied by 0.08. So we have a total of $21.36. So we both add them up. So we have $5.33 plus $21.36, and we have a total of $26.69.
So, Mr. Chamber, there are sources claiming that using an order interval other than 6 weeks would reduce costs. What can you say about this?
Well, currently, the company is under the deliberation of discussing the studies of our operation manager as to regard what is best for the business. At the moment, we are still using 6-week ordering system since it will take cost of conducting changes in the system. We are hearing experts say about this.
And that is all for the UPD Manufacturing Purchasing Manager, Mr. Chamber. The company is under the deliberation on what actions needed to be taken for them to reduce costs. Jaira?
Thank you, Hazel from BBBR Radio. And now we have online the operation manager and specialist, Miss Justine, to hear what she wanted to say about this matter.
So to understand the order interval other than every 6 weeks reduces cost or not, we need to calculate the operation using the economic order quantity and fixed order interval. So we have a given here, which is cost per order, which is $32, number of kits, which is 89 kits, and carrying cost of $0.08, and demand for weekly, which is 6 weeks. So for the first method, we have fixed order interval method. We must get the quantity ordered equals demand for weekly multiplied by the number of kits. So we can get 6 weeks times 89 kits. We can get the quantity ordered as 534. So we also need to get the total annual cost for ordering, which is equals to total order cost plus total carrying cost. So number of order cost times the order cost plus average inventory times the annual carrying cost. So we assume that weeks in a year we have 52 weeks. So 52 divided by 6 weeks times $32, which is the cost per order, plus 534, which is the quantity ordered, divided by 2 times $0.08 times 52 weeks. We can get 277.33 plus 110.72, and it is equals to 1,388.05. That is the total cost for ordering. While the economic order quantity method is that quantity ordered is equals to square root of 2 multiplied by the annual demand multiplied by the ordering cost divided by the annual carrying cost. So we assumed earlier that we have 52 weeks in a year. So we need to divide it by the number of kids, which is 89 kids, so we can get the total annual demand, which is 4,628. So square root of 2 multiplied by 4,628 multiplied by $32 divided by 0.08 times 52 is equals to square root of 296,192 divided by 4.16. So we can get square root of 71,200. So square root of 71,200 we can get 266.83 or round off to 267 units. You should also get the total annual cost for ordering cost, which is equals to total order cost plus the total carrying cost. So it is equals to number of order multiplied by the order cost plus the average inventory multiplied by the annual carrying cost. So we can get 52 times 89 divided by 267 units times $32 plus 267 units divided by 2 times $0.08 times 52 weeks. So we can get 1,110.03. So now let's compare the order if it is placed at 3 weeks and 6 weeks. So for the 3 weeks, we need to get the order rate, which is equals to quantity order over annual demand, which is 267 units over 89 kits. We can get 3 weeks. And also to get the quantity order, we need to multiply 89 kits to 3 weeks, so we can get 267 units. First, we need to get the average weekly ordering cost, which is equals to annual demand divided by economic order quantity multiplied by cost per order. So we have now 89 divided by 267 units multiplied by $32. We can get $10.67. Next, we also need to get the average weekly carrying cost, which is equals to order quantity divided by 2 multiplied by the annual carrying cost. So 267 units divided by 2 multiplied by $0.08, we can get $10.68. So the total cost is $10.67 plus 10.68, we can get $21.35. So if the order is placed at 6 weeks, so you can get the quantity as 534, which is we multiplied 89 gigs to the demand for weekly, which is 6 weeks. So first we need to get the average weekly ordering cost. So 89 over 534 multiplied by $30, we can get $5.33. While the average weekly carrying cost is equals to 534 over 2 multiplied by 0.08, we can get $21.36. So the total cost is 5.33 plus 21.36 is we can get $26.69. As we can see here, The 3 weeks, if the order is placed at 3 weeks, the company can save some cost. And the perfect order for that, quantity order for that is 267 units. So if we subtract $1,388.05 to $1,110.02, you can save 278.02 annually by using economic order quantity. And while the best order to be placed at is at 3 weeks, and the great optimal size for it is 267 units per order.
I see clearly that using EOQ you will save the amount of $278.02, which you will get from subtracting 1,388.05 and 1,110.03.
Yes, the company will save some cost.
Would you recommend changing to the optimal order interval?
Yes, I recommend changing the optimal order interval instead of using every 6 weeks to help reduce some cost. Because the best formula for this is economic order quantity method. Because by applying this method, it will help the company minimize the cost and maximize the value when restocking inventory.
Thank you for that wonderful recommendation, Ms. Justine. UPD manufacturing takes consideration of what will be the best course of action for the matter of using EOQ method that helps calculate the optimal order quantity to minimize the cost and improve overall efficiency. And this has been Jera Nasal Batran of JJDH News.